Okay, so I'm going to be talking about generic error handling in JavaScript. A little bit about myself. My name is Alex Gorbatchev. I'm on GitHub and Twitter, of course. My last name might sound a little bit familiar to you. You might remember this guy from Russia. He made some news once in a while back here as well. So Mikhail Gorbachev. The only difference is I have a letter T in my name, which gives me all sorts of advantages, like getting a .com and so forth. So that's pretty cool. I love JavaScript. I love CoffeeScript even more, and I'm not ashamed to admit it. I don't know if you like it or not.
Yeah, CoffeeScript.
Yeah. Okay. Awesome. So in this talk, we're going to cover try-catch, callbacks, and promises, and how it all kind of works together. So to kick off, let's look at a code sample. We have a fully synchronous function that, does something. Doesn't really matter what it does, but basically we have three functions and a JSON parse in the middle there, and all of this flows together, and we basically call it, very simple like so. And so when the function is done, we console log that we're good. So let's have a look at, if something throws an error in the parent function, all we got to do is wrap our call and try catch and process our stack. So that's pretty simple, but what happens if one of your functions needs to be asynchronous? And so we need to deal with that. That is never pleasant, and we're going to look at how to work with this. So to modify the original function a little bit, we're going to make the last function process dependencies asynchronous. And so what we need to do is we need to pass in the error back or a callback in here, and one more time to our function that is asynchronous. And so then our original execution code is going to look something like this. We call append dependencies and pass a callback function, which takes the first argument as an error. And we handle it. If there's an error, we console log. Otherwise, we're OK. So, what can possibly go wrong in this case, right? So let's look at this thing again and look at a couple of lines of code here. What happens if this guy throws an error? Or if the JSON that was read is invalid and JSON parse throws an error. Or this one might also do something, and God knows what happens there. But in any case, so we can handle the first three with a basic try-catch. And so now we have a synchronous function that takes another function, handles error there, and then just in case wraps it in try-catch and handles error again. That gets pretty gnarly. So let's try to rewrite the whole function, assuming that all of our API is asynchronous. So in this case, we have three original function calls that we're working with. I guess four. Those are the same APIs that we called earlier. In this case, they're just asynchronous. And we're handling errors in three places. It's not too bad. We're kind of taking care of that. And we're calling our original function, processing the error stack, the error, and console logging. Again, it seems like pretty good, right? But what happens if this function that is at the top of here happens to do something really bad, and instead of passing an error, it blows up? Well, there is no opportunity for us to handle that error, right? Again, we have to wrap the damn guy. So we wrap again with a try-catch, and we have a synchronous function. That just gets pretty bad again, all over the place. What about these two ones? So these are now inside an asynchronous call as a callback. And what if one of them blows up in an unexpected way? The errors will just throw in the global context, and we don't have an opportunity to catch. So how do we mitigate that? Well, we do some more try-catch. this is starting to just get really, really gnarly. So that's not how you're supposed to do this. This is, I'm like going down the bad way here, which, makes me really sad. So how do we kind of work with this? Well, this is where the promises can come and help us out. So from the spec in the first paragraph, it says what a promise is. A promise represents the eventual result of an asynchronous operation. Let's look at our original synchronous function and what it looked like in the beginning. So each function here returns a value because it operates asynchronously. If we were going to rewrite this using promises, instead of returning values, we're going to have to return promises in this case. And so what we could do is, using the .then API, we can chain and rewrite our synchronous function in an asynchronous way, assuming that each of our functions returns a promise. And that looks something like this. So this is a very line-by-line equivalent to the previous function. So this guy here and this almost an equivalent, just rewritten in asynchronous way. So let's break it down a little bit. The first call of the find package returns a promise that is then returned out of our function. At some point in the future, when the find package finishes at work, the promise is resolved. And when the promise is resolved, then our then handler is executed with the value that the promise was resolved with. In this case, it's some kind of a content that was read that's supposed to be JSON. In here, we JSON parse the content and return the value. So the interesting thing about this is the JSON parse does not return a promise, but instead returns a value. And according to the promises spec, this should be permissified, in a sense, the return value, and automatically resolved, which brings us to the next step, where the JSON that was parsed passed into this function, something happens here, promise is returned, and so forth. And finally, this chain completes with another promise being resolved and returned. And so this is what our original call looks like now using promises. When the chain unravels, everything completes successfully, the done callback is executed, and we're good. And if at any point during that function call anywhere in any of the promises handling there is an exception, this is basically passed to the catch handler, and we can handle our stack. So we don't have to worry about try catching in multiple places. This goes pretty smoothly. So let's look back at our function again. This is where the promise is starting to kind of come together a little bit. And let's look closer here at this place. So the parent function receives the content and passes the content right back to the JSON parse, which returns the value. Well, we could kind of shorten that a little bit and rewrite it like so. So that looks pretty nice. And then this guy and this guy do exactly the same thing. Each one receives an argument, passes the argument, returns the promise. So we can shorten that again. And so now our control flow looks pretty manageable and exceptionally easy to read. So let's look at them side by side with our original try catch. So this is a fully synchronous function that we had originally that is executed synchronously, and this is our try catch to call our synchronous function. Now, when we write the same function with promises API, we have an equivalent asynchronous function where everything happens asynchronously except for the JSON parse, and our equivalent call, which handles an error and displays success. Purely coincidentally, it's exactly the same line numbers. But I think that's kind of awesome that you can rewrite your API, and it doesn't get much bigger in terms of line counts. And so we have great success. That's it.
Any questions for Alex?
Yeah, so with promises, when with the last line that you have the catch, the catch method, does that kind of because what I normally use when I use promises, I also use reject as well. So is that a way to sort of say you don't need to use the reject keyword? Because whenever I sometimes I have chains like 3 or 4, and I'll use those. I didn't know that there was like a .catch that you can use.
So this is basically for any errors that happens in the flow, right? So if any exceptions are thrown, I'm actually not quite sure if the rejects will come in here as well. The rejects generally can put in the then, but I think catch should also grab rejects as well. Actually, but I might be wrong on that one.
It will catch the reject.
It will?
Reject an arrow, it will catch it.
If you reject it, but what if, like in this case, you're not using rejects, right? You're using just resolves.
Oh, but one of those functions, like find dependencies, could be resolving with a rejection. Well, sorry, like it could be rejecting with an implicitly rejecting with an arrow, right? In one of those functions. Is that
the way I understood whenever I use promises is that I explicitly say that I'm going to resolve something, and then I'm going to reject something if there's some sort of error. So, are you saying that there's
but that's in the definition of one of those functions within the then.
Okay.
Right,
gotcha.
because in one of those functions, those are promises, right? So they either resolve or reject something. Does that make sense?
Yeah. Okay. So, answers my question.
Great.
Thanks.
More questions? Yes.
On the left side, is that really a synchronized?
I'm sorry?
On the left side, is that really on the top, the update dependency?
Yeah.
Is that really a synchronized?
Yeah. So assuming.
I think it's asynchronized. Because, for example, like if find package takes 3 seconds, I believe that they will.
It's a synchronous call, yeah. So the entire process will log for 3 seconds on the left side.
Then one by one.
Yeah. Yeah, and so that's the advantage of doing it in an asynchronous way. Assuming your functions behave more or less okay, but you have a long-running AJAX call or database query, your process doesn't lock up, or your browser.